Hi, I'm Alan Ross. I am the managing editor and co-founder of APC Media, and this is a power panel with some great people in the power panel. Our topic today is going to be monitoring, diagnostics, maintenance, and reliability. And the idea is that we do less maintenance and do a lot more reliability. Our guests today are Brad Bowness from Systems with Intelligence. Brad's, thanks for joining us. I love your mind. We've done some things together before. Emilio Morales, who he and I go a long way back, don't we? Back to the days when I came and listened and learned from you. Bob Rasor, I worked with Bob at SDMyers for years. Bob's one of my heroes. We're both mechanical engineers doing stuff in the electrical industry. Yeah, and Mark Tostrud. Mark is with Dynamic Ratings and also one of the go-to people at APC Media for content. So, gentlemen, thank you so much for joining us. This is an honor.
Thank you, Alan.
So let's go, and you're going to kind of people can read here, but I've met Mark. You did some stuff for us where you've written some articles for us. Is that correct?
Yeah, I've done a number of, contributed a number of articles to the magazine, and I've been around in the industry for quite some time. My history is basically, I started out in the utility industry, so had almost 19, a little over 19 years at We Energies, and most of that was focused on implementation of condition-based monitoring programs. But that was sort of before there was a lot of online monitoring. So,
And that's why
uh,
you're here, because of that. And yeah, it's a major thing that's going on in the power industry right now. More change than in probably the last half century, right?
exactly. There's been a lot of movement, and but what's exciting today is that we're really getting to the point where we're using that data. So,
Yeah, excellent. We're going to talk about that. Our oh, he's got some things about the Emilio. Oh, you look so young there. I love that.
No, that's an old picture. I haven't got a new one yet.
Okay, well, we'll
I
we'll
even
try
don't have
to
a mustache.
we'll try to fake it and get a new one. I first met Emilio when he was teaching at a Megger conference, if I remember, at a Megger
No,
event.
actually, it was a Comet conference, something
Comment.
that
Oh yeah, yeah, yeah. The Qualitrol co put on with the University of Texas Center for
exactly.
Electro. Yeah, that was great. So, Emilio, talk a little bit about your background.
Well, since I got a college, start working on transformer industry, basically designing power transformers. I work in that industry for almost 32 years in 4 different companies until I joined Qualitrol back in 2012. My job there is basically a position called is technical application specialist, support development of new products, support customers, attend conference, and represent Qualitrol in the different standard organizations, IEC, IEEE, Secret.
Excellent. Yeah, and we're really he's one of our technical advisory board members, which means we covet his ability to write technical articles that helps others in the industry create safe and reliable work practices. Next up, we've got waiting for that. Yeah, next up we got Bob Rasor. Bob, as I said, is an old friend. We've known each other now probably 30 years. Bob, is that right?
Yeah, been a while, Alan.
Yeah, a
It's good
little
talk.
while, Alan. We don't
It's
like to
good
talk
talking
about.
with you. That picture, mine's a little bit aged as well.
I
That's
know,
really
I know. Okay, that's when your hair was brown and now it's quite gray. We got to get all these pictures fixed because my picture in the magazine looks like yours and it was 10 years old. I'm not the same anymore. Bob, talk a little bit about your background. You've worked for 400 different companies, haven't you?
yeah, one. Uh,
I know.
since
Since
college,
college,
yeah,
one
40,
company.
47 years now at Myers. I'm currently the director of transformer services, and I've seen a lot of change in the transformer world from the big, strong, sturdy ones to the finely tuned, smaller, less available transformers. So most of my career has been around transformers and reliability. That includes being on IEEE for a couple decades, interacting with folks there that really understand transformers and standards. That's been a great learning place. As a mechanical engineer, I also always been amazed to see the connection between not just the electrical, but the cooling, the construction, repair, testing. chemical science. They're all a part of this topic for today. Thanks for having me, Alan.
Great, thank you, Bob. And I know the info that you bring to it. And lastly, Brad Bowness, Systems with Intelligence. I know his CEO, Angelo, and I love what they do, and I love how you guys you've got a unique take on monitoring. So we'll find out more about that later. But Brad, thank you.
Yeah, no, pleasure to be here today. And just a little background on me. I started my career in consulting, and then I had the benefit of spending almost 20 years with a large transmission distribution utility, and saw things from many dimensions, from operations as well as from the technology transformation side of things, and sort of bookended things with being back in more of a consulting role now, working with our customers, hearing their challenges, being a voice back to our company around what we can do to help utilities improve, and really enjoying working with a number of global utilities on helping them with their condition-based maintenance programs.
Excellent. Thank you, Brad. Here's how we're going to do this for the panelists know this, but this is for the audience. One of our panelists will answer a question that we have predetermined, and then the other panelists will weigh in on it. I mean, if somebody says the earth is flat and you want to say, no, the earth is round, you weigh in on it. But really, you can't grasp the fullness of each of these questions with just one person answering. So it's more of a dialogue that we'll have going back and forth with each question. So the first one, the one that gets picked right out of the bat is Emilio. This one's for you, Emilio. So let's talk about monitoring and diagnostic from a general sense. For a number of reasons, the entire world, this thing called monitoring and diagnostics is growing, and it's growing fast. From your perspective, where are we right now when it comes to monitoring? And try not to focus on transformers alone monitoring, but look at total, because we're doing a lot more monitoring of all electrical equipment, or all mechanical equipment too. So look at monitoring and diagnostics in general.
Well, I would say that right now, monitoring diagnostic is evolving rapidly, like you said, not only for transformers, and not only for the electric industry, it's for all the industry. So basically, it's driven by advances, new sensor technology, data analytics, and the use of AI. So we are at a point where real-time data collection is not the challenge anymore. The challenge is how do we process, interpret, act based on that information now, that data. So that's what defines now the current state of monitoring and diagnostics. Another thing that is evolving is also, and everybody is aware of that, is cybersecurity challenges. So in short, monitoring and diagnostics is shifting from being reactive to proactive, from isolated to integrated, and from raw data to intelligent decision making. Now, that's the challenge for those companies that are already into, let's say, comprehensive monitoring systems. The issue that I see now also is for those companies that are not there yet. Yeah. Let's say today somebody wants to implement a monitoring system in their transformers, new transformers. So, I mean, they have to first put that in the spec. That takes time. Then they go to a bid. Then that takes time as well. And then they give the PO to the OEM. And now, with the lead times, when would that happen? It may take 5-6 years now. So for those companies that are not on board yet, it may take a lot of time now because of the situation of the market as well. Yeah. So that's basically where we are now.
Excellent, excellent. You all can weigh in on that. That's not anything that you can disagree with, okay? He said the earth is round, and we all agree that the earth is round. Well, yeah, very well said. First of all, Brad, any comments, any thoughts about what Emilio, and by the way, he gets to rebut, right? If you say something. No,
for sure. And Emilio covered, a lot of the sort of technical aspects of sensors and the fact that a number of utilities are moving forward with programs like this. But I think at a macro level, utilities are under a lot of pressure. They're under a lot of pressure to harness their existing asset base to its fullest, right? Regulators and investors and customers from a rate base and an impact on rates perspective are really looking for utilities to get the most out of their existing assets. So putting monitors in place is allowing utilities to make better decisions, have better insight on their assets, and stretch the life of the existing asset base. Utilities also have a lot of pressure from a maintenance cost perspective. So looking at ways to automate and digitize legacy maintenance processes, taking advantage of the lower cost of sensors now, and then bringing that together into a centralized data and analytics group. I think the number of data scientists and data M&D centers and condition-based maintenance groups that are coming up within utilities are really investing in this data and analytics space, and with the input of the field sensors, really looking to make more informed decisions. So I really think the M&D space is just going to continue to progress and take off here over the next number of years.
Yeah, I agree. I think I'm not sure which is a great Northeast organization hired more data centers a couple of years ago than they hired electrical engineers. They're scientists, data center scientists or data scientists. Bob, weigh in on what you heard both Brad and Emilio say.
We get a blended view of utilities. We're heavy in the industrial space.
Yeah.
So we have some limitation on the asset's value as to how much can be invested into the transformer, but we're definitely seeing the value of, continual data to, bring around, actions that'll save the transformer from, unplanned outage. That's where we're in the space of protecting our customers from, they may be very good at it, or they may have no time to even think about it. We get in there and collaborate. That's mostly our role, and I agree with everything I've heard so far.
Excellent. One of the things too I know is the same problems that Emilio said the utility industry had, that Brad said the industrials and data centers have the same problems. They have an aging structure. They don't want to spend capital, whereas utilities can spend capital to do it. Well, industrials don't, and they hate maintenance. They want to cut maintenance dollars. So keeping existing assets alive is as important to them as it is to the utility world. So yeah, you're right. Mark, you get to go last on this, but first on the next one.
Thanks, Alan. So yeah, I agree, with utilities have a lot of challenges. I mean, they're still facing, the aging workforce and stuff like that, and the expertise of how they used to do business is, as those people retire, the newer people aren't exposed to the same, the equipment as often. So they have some challenges. So then they start turning to monitoring. You talked about the aging infrastructure as well. So they have some challenges there. So, they've got less O&M dollars to work with, but at the same time, a growing asset base that they need to monitor and maintain and things like that. So it's becoming more challenging. One of the things that Emilio had pointed out was that, we're seeing a real merging of the data from multiple sensors, multiple technologies, all coming together and making more, better use of that. One thing that I've said in the past and, in other presentations and stuff, one of the drivers I see is, we're really not building a utility infrastructure for you and I. We're building this for our kids and our grandkids.
Yeah.
And they do things differently. And I say it often, if it's not here, it doesn't exist.
Yeah.
And so, bringing that data together and putting it in a place where, so it's easily accessible so they can see it and react to it is key here.
Excellent. That is a great point. The next generation is very mobile, and it comes from this. More on that and one of the other, because we're talking about communications in the future. Any other thoughts just on the general? I think you all have covered it pretty well, but let's go to the next one. So now we're gonna drill down. Because I have transformer oil in my blood, as does Emilio and Brad and Mark and Bob. We know the heart of the system is the transformer. But Mark, for you, the most important asset in a modern grid at the utility, at the industrial, at the data center right now are transformers. They are aging more rapidly because of DER. I mean, once you create an inverter-based system, they're aging at twice the rate. Instead of 1% a year, it's now a little bit over 2% a year, last statistics. And their utilities particularly are overloading because of weather events. When it's really hot in Houston, everybody's running at full power. But talk about transformer monitoring and diagnostics more specifically. How did it get started? You kind of mentioned your long history in it. Where are we now, and where do you think we're going?
Sure. Thanks, Alan. So, when people talk about monitoring, they often, there's been monitoring in many different formats over the years. I mean, in a sense, I mean, a typical gauge that's giving you an alarm output when a transformer's overheated is monitoring in some people's, some aspects, but those types of devices, the old gauges and things like that, they worked well. They got us where we are today, but they didn't really have as much predictive capabilities. And what we're really seeing today is a movement more towards predictive monitoring. How can I get advance warning of what's happening on the assets so that I can make better decisions? So when companies talk about, so that's the first thing, is we want monitoring that's more, more predictive in nature. When you talk about an asset manager, they, historically, it was almost an oxymoron, because, they talked about asset management. It's been around for years, but oftentimes they really didn't have the data to manage the assets properly. It was like, okay, I got a DGA once a year and I'm supposed to decide how healthy my fleet is or my transformer is, or can I overload it? And that could be very challenging. We're really getting on this, so people are really starting to make use of that data, but it's more than just the monitor. It's bringing it back, putting on a dashboard, making that data accessible for everybody in the company to see, so that they can leverage it. And, so there's a process that we go through in the course of doing that. I mean, the first step is getting that monitor in place, but then we got to get the data out of the monitor and make sure that, some data validation, making sure that it's accurate. And then from there, putting it into a dashboard type format so that it's accessible to others. And then, deciding, how the layout is going to be, because obviously we need to do some fixed screens and things like that, control the views. So there's a big push. It's no longer just about, it's gone through this transition, more predictive in nature. But then as we get, now we've got those monitors out there, and now we got to get the data back. And then we got to start putting it into the dashboard formats and leveraging it, whether it's out of, Pi or the other, the data historian that we're working with. So it continues to evolve. And companies are still challenged with that aspect of it, because it takes more of a vision. It's not just about the monitor. It takes a vision as to where you're going and what you want it to look like in 5 or 10 years.
Wow, that's excellent. It takes a village and it takes a vision. You're exactly right. I just had a discussion with a company, Cheniere, a refining company, and that's almost, we didn't use the word vision, Mark, but the idea was, what does it look like in your electrical maintenance program? And you know what the answer was? I hate to say this, but they really are just at the starting to put one together. And so they didn't have a vision for it, but it starts there. Bob, anything to add, or anything to add or build upon from what you just heard from Mark? Because I know SDMyers, your company, it's primarily testing, oil testing. You pull it out, you test it. It's the largest lab in the world. However, you all have moved into a significantly more monitoring approach. I know you personally have developed some systems, and it's all about data and making decisions. Talk a little bit about that.
Yeah, one of the words I heard Mark use that always rings a bell is that word predictive. Tied to predictive has to be, multiple data points. Getting one sample a year, as you mentioned, can be way misleading, even in the world of moisture, depending on when the sample is drawn, the load, and so forth. So we like to use trending as a very powerful tool. And one of the best ways to trend is more data. So, with knowledge, that's great, and data is great. And then tied to that is the wisdom as to where it all leads us. So I just think the trending part of what we've experienced can lead to the best decisions to keep, transformers reliable and power systems reliable.
Yeah, I used to say as an engineer, I would say, if you give me one data point, I can't tell you anything. If you give me two data points, I can lie and tell you it's a trend. But if you really want to know what's going to happen, we have to extrapolate from 1,000 data points, and you always lose them because they don't have 1,000 data points. Excellent, thank you. Brad, same question. Weigh in on what Mark has just shared.
Yeah, I think the piece I'd add over and above the trending aspect is, you have to get to some sort of critical mass. Utilities especially are really good at piloting things, right? You can always get a bit of money out of an R&D group or a innovation group in order to move forward with trying something new within a utility. That was my experience. But to get into the sort of programmatic view, you have to have some wins. And I think that's what we're starting to see is we're seeing a number of real world examples coming from utilities where we are seeing those wins or those saves, right? Where they have deployed to a critical mass of some sort of monitor. And that's leading to some aha moments where people are saying, yeah, if I start to deploy this across the fleet, I can now bring this data into a centralized repository, start to look for insights, start to correlate data with my load and my performance and my customer criticality data. And now I'm starting to make a truly informed decision and have a true health index around the power equipment. But I do think you have to have that vision. You have to have that sponsorship. You really have to go into this thinking we are trying to build the monitoring and grid and capabilities for the next 25 to 50 years. And in order to do that, we have to be programmatic about it. And we can't just be treating these as R&D projects or innovation projects. They really have to have that vision and sponsorship to get to that critical volume of data to generate the insights.
It's very interesting that major change in any organization, it can't start at the top and be pushed down. They seldom work. Can't just start grassroots because if they're not there, they are the two combined. And then they say, what are we trying to accomplish? And the word is to what end? And I love what you said, Mark. To what end? We're building a reliable system for our grandchildren and their children. You're right. That's exactly where we have to be. Industrial, data centers, hospitals, utilities, whatever it is. To what end is we're building reliability? Emilio, I'm sorry, I just went off right there, but go ahead.
Well, I completely agree with all of them. I mean, trending, like Brad said, not only trend, the correlation between parameters can tell you what type of failure mode you're dealing with. But another thing that I would like to add is that companies that develop this type of monitoring systems have some issues regarding not access to the data. The end users don't want or don't like to share the data they have, that it could be like a mine for us, and look at that. So right now, more likely, monitoring companies have to rely on theory about how the component fails, the failure mode, the symptoms and parameters, how they trend, how they correlate, rather than it would be really nice if we could have the data to confirm that. So the way these things work is we implement something, and if something happens, oh, it worked. It's a big deal for us in that way.
Data. I mean, every one of you mentioned and keep talking about data. Thank you, Mark. I think the idea that we look at this differently as a vision is important. Here's the problem, and Bob, you're going to answer this one. there are challenges at the industry, whether it's the utility, and maybe they're a little bit more prone to it now because, as Brad said, we've had some wins, and you can go in and say, here's a win, here's what it looks like. But we're giving information to the people that not necessarily make the plant or local decision, the corporate decision. So when it comes to getting a monitoring and diagnostic approved at whatever level, and you're asking for long-term capital or maybe increases in operational budgets, especially for the installed base of transformers. Right now, people are spending capital to buy new transformers, but we've got to keep the installed base running longer because we can't get transformers as fast as we need them. The global transformer market we can get, but when you take China production out, North America and Europe is in deep trouble, including with all of the upcoming, everybody's adding plant, new capacity. We're still going to run short of the transformers that we need. So it's growing harder to get replacements. And I know you've dealt with simple one-off situations in this, and Bob, you've dealt with fleet-wide. Hey, how are we going to make decisions about that? But share some of your experience with getting buy-in from that corporate entity to what Mark said. It's got to be a vision for change.
Oh, great, great question. A couple things come to mind. Budgets are a big driver in decisions, and when the critical moment hits, the money will show up. We want to avoid the conditions where the money's huge, and so we have to make decisions along the way. And I want to talk a little bit about just spare transformers. When we're looking at trending and we see an older transformer that's starting to have, I forget who mentioned it, but you correlate different readings. You might look at gas levels. You might look at leaks because of it's 30 years old and the gaskets are starting to let go. And you look at perhaps some data chemical wise, like furan content, and you see that the transformer's on its way out. You've got to make sure you've got a plan in place for when it does go out, you're not scrambling, because the scrambling places to go, they can be problematic. Sometimes you'll get, I hate the word lucky, but you could find one and you'd be great in good shape to get it replaced quickly. Other times you're on a waiting list for 6 months. So spares are very important to strategically pick size. Is it not just the kVA, the voltage, the impedance, it's also the fit. If you've got a spare that can go in a couple different places, you want to analyze, all of your system, your fleet, and make sure you've got the right spares and the right plan in place for when things do happen. You're going to minimize. You could have the spare ready to go, and you're resilient. You get right back into shape. And so we found that monitoring-wise, we've talked a lot about instruments, but back to the basics of just simple visual inspections, oil testing, and even infrared scanning. Those are called out recently in a sort of a guide format in NFPA 70B. We're all familiar with 70E, which is the safety aspects of transformers and substations and electrical. In the electrical world, 70B starts to talk about guidelines for testing, annual testing for transformers with liquids, and they go into electrical testing every 3 to 5 years. Well, you don't want to spend too much money on something that's running fine, but you also have some of these regulations coming down to say, hey, if you had an event and you weren't following something, here's where you might have gone wrong. So capital money is hard to come by. Spares are very important, and you have to make sure you're ready when the unthinkable could happen. It might just not be an aging transformer. It could be a catastrophic event. We've all seen our world experiencing tragedy. Fires and windstorms and floods, and having yourself a plan in place is where wisdom comes in, and that's where we see a lot of this going. And coupled to that is just a simple DGA test. that you see evidence that maybe a de-energized tap switch is coking up. That is a very simple repair. You get in there and you open it up and you electrical test, you see what's going on, and you fix the switch, hardwire it, get it right back into shape. Where if that transformer went out unexpectedly, the consequences are way different. So
No, I know, Bob, that we had a situation. I'm sorry. I know, Bob, we had a situation on a spare situation that when they went to the spare, the bushings were gone, or half of the bushings were gone. There were no gauges on it. This was not ready to go into service immediately. So that, I've seen that happen, and that your spares program, I think it was it was Gerdau Steel and a friend of ours who developed the best spares program I'd ever seen across his fleet, so that he had the ability to do it. Next up, Brad, you get to weigh in on what Bob said. So up to you.
Yeah, no, for sure. And in the context of sort of, the approval process, with getting moving on these programs, right? It does take a long time to get into the capital planning process, or even into the maintenance release of funds process. Long regulatory cycles, long business planning cycles. But the challenge that you have in this space is that if you don't get started, it's very different. It's very difficult to catch up, right? Some of these sensors that need to be installed require outages. The work needs to be planned with existing work that might be occurring at a substation. And this really, the whole M&D space and implementation of monitors and sensors should be done on a programmatic basis. You should be rolling through your fleet, month over month, quarter over quarter, and starting to gather this data so that you can start to get those insights in those centralized systems. But if you don't do it, then all of a sudden you have a major event. Then somebody's going to say, well, why haven't we been doing this? There's been so many, saves and success stories in other utilities. Why didn't we do this? And then it's a hurry up and get it done. And then you have the constraints of resourcing, other projects, outage constraints, and the such. And it's very, very difficult to catch up. So, if you think about doing this on a true programmatic basis based on maybe some other utility successes, right? Maybe it's not your own internal successes, but there's enough success stories out there to draw upon so that you can be ahead of this and be able to make those great decisions so that you don't end up with those catastrophic failures that you'll end up having to explain to a regulator or internal board or customers or the such in the future.
One of the things we're trying to do at APC Media, and Brad, you did this. You brought one of those successes. Here's what happened. Here's what it's doing from the end user, and we're trying to publish many more of those so that we can share. And it's as Emilio said, a lot of people don't want to share their data. Well, don't make it proprietary data, but make the industry better. Mark, you brought vision in, and now we've got predictive. And now we've got shared successes. Add to what Bob and Brad have said.
So I think, Brad really hit it on the head. You need to address both your new assets, which is sort of the easier part because I can write a monitoring spec for my new assets and stuff.
Right.
The challenge is you also need, if the lead time on that asset's going to be 3 years, you need to be predictive enough as to where you think you're going so that you're not, because what you're monitoring today may not exactly match what you want to monitor 3 years from now. So you need to write it open-ended enough so that as the technology evolves that you can, still get that into the spec without a change order, which can be, a little challenging and stuff. But, so, you got that piece you need to address. And as Brad said, you really need to address the existing fleet too. That's certainly challenging because, to get those dollars to be able to do that. Now there's pressures, with NFPA and NERC and stuff like that they're mandating a certain level of maintenance, monitoring as a way to offset some of that. But it's very difficult to justify a monitoring program based on maintenance dollars alone. It's really difficult because there's just not enough savings there. You need to start looking at avoided cost of preventing failures, the environmental damage that would occur, even on critical assets, what it's going to cost your customers if you had an outage on that piece of equipment and stuff. And once you start including some of those, the more of the hidden costs and things like that, then it becomes much easier to, to cost justify doing this on your fleet.
Yeah, that has been one of the difficult things. It's you're not going to cut costs when you add in monitoring diagnostics program. And if you consider it as maintenance, there isn't a CEO in the world that wants to spend more money on maintenance. It's a cost center, right? So how do you make, it's not going to make you more profit, but it can certainly keep the profit flowing if it doesn't fail. We've had enough cases, and they are now publicly cases. In fact, I know we've written several articles at APC Media. One of them shares a $52 million loss from a transformer that Bob Rasor knew was going to fail, and they didn't take it out of service, and they didn't have a spare, and it was a $52 million loss. Loss of jobs, there was just a lot going on. And that question was this: why didn't somebody do something about this? Sorry, that one stands in mind. That just drives me crazy.
Yeah, it only takes one save to just, cost justify doing monitoring on your whole fleet.
Exactly. It's like you spend $2 million in your monitoring program and you won't lose $52 million. Emilio, same question, different answer, same question.
Well, I'm gonna go to the practical part. Yes, I whenever I do, visit customers or in a seminar, people will ask, okay, so what should we do? And it's like, well, it's like, what transformers do we have to monitor, or what do we monitor? So sometimes I tell them, well, look at the different failures you have had, and try to address those first.
Yeah.
The other thing it is, justification wise, in a very practical way or very simple way, the guy for the application of diagnostic monitoring equipment, IEEE 57 143. Right now, the actual one is 2012. I'm gonna guess 2025. We work on that. It's about to be published. Has a chapter or clause that talks about justification, how to justify. And it's a guide. There can be other ways to do it. That one gives very practical examples. I'm right now part of a secret group where we are trying to define methods to determine the criticality of the assets. So to be able to get value in that. And the other thing, from the practical point of view, those companies that already have given a PO to an OEM for a transformer that will be delivered in 3-4 years that doesn't have any monitoring equipment. One thing would be to prepare those units to receive monitoring equipment in the future. It's very simple. It's not high cost, could be a very standard way of doing things, and then move on and be ready for those transformers when they come out of the shop.
It's like when you have a forest fire, it's putting a fire break in, right? Hey, in the future, you can avoid the problem by putting it in the spec, as Mark said, right? Make sure it's in the spec. And then, Mark, that was really good. 3 years from now, you might have to change that spec, and you know how hard that stuff is. But yeah, fix it in the future. And then now we're coming back and saying, how do we fix it now for the existing things? This last one we're going to move on to is our last question. You've heard the challenges. You take all of this that goes on here. In terms of, we've kind of said it, but I really want you to kind of nail it down. What is the value proposition for implementing a monitoring and diagnostics program? Not buying a monitor, but implementing. You can either do it at a plant level or you can do it at a fleet level. But when you look at this, practitioners out there are the people that have to make the decisions. They're either in charge of the electrical system or they're in charge of controls. Make a case for the value proposition for a monitoring and diagnostics program.
Yeah, I'll jump in there, Alan. So I think, the first thing from my perspective is people that are working within the utility, that are working, running the day-to-day, are super busy. They're dealing with outages, they're dealing with projects, they're dealing with customer issues, regulatory issues, everything that's coming at them. And it's hard to find time in the day to think about things from a value proposition perspective. So I do think being able to pull somebody out of the sort of day to day and giving them that business champion role and having them have some time to think is really important to be able to come up with that sort of internal value proposition that's going to land well with the decision making process. And then once that person is sort of identified, I think, the starting point should be the base case. Really challenging yourself internally to say, well, what is our base case? How much do we spend on maintenance today? How much do we spend on preventative maintenance, corrective maintenance? What is the value of extending assets by 2-3 years of their 50-year life? What is the cost of having that major catastrophic failure? Maybe it's not 52 million. Maybe the average cost of a major failure is 5 million. Well, how frequently does that happen? Okay, so now I understand my base case. And now I say, what can I do differently? I can do things differently. I can implement monitoring, diagnostics, tools, capabilities, processes, systems, analytics. And these are the things I can impact on that base case. And now I have my value proposition. So now you've been able to craft that overall story, and that value proposition is based on things internal as well as success stories in the marketplace. Yeah. Now you just do an ROI. What can I do here? What can I influence? What's available in the marketplace? The cost of these solutions have come way down. I now have a really positive business case I can bring forward and take up the line to have funds allocated to my program. So I think really looking at that and going through that process is really important to being able to move forward with this type of initiative.
Darn, I'm sold. I mean, that's excellent. That really is it. What is it in reliability? It's the severity and frequency. And if you look at those two, you create, that's your risk factor. So there is a way to measure that we look at and say, hey, this is what it's going to cost you. Again, it's not going to create more profit for you, and it's not a maintenance cost, but what it is, a predictive tool. So you got the first on this one, Emilio. Anything to add to what Brad has said I've heard you give your value proposition, so you want to do it again?
Well, I think something else to add is there is also in the industry a lack of engineers, and that's a big deal. And that comes with, the expert subject matter getting retired.
Yeah.
And where that knowledge goes. So we have that situation, and that's another value of monitoring or system where you can integrate that experience of people, with experience, expert subject matters, into the system. So when you have identified a problem, the problem is identified as a failure mode, and then come with actions about what needs to be done. Now, that's one of the values. Another value is there is a study, not specifically on transformers. It was basically in GIS, the gas insulated switch substations, where a lot of failures took place because of maintenance that was not needed.
Yeah.
So that's another issue. Going from time-based to condition-based or reliability-based, and avoid those possible mistakes that can cause a failure.
Absolutely. Breakers, particularly, when they do the time-based part, they've caused more problems, and when they do monitoring, they can save a lot of time, money, and effort. Bob, same thing. The value to doing a monitoring and diagnostic program.
Well, what comes to mind is, I think you touched on it there, Brad, about having a person or a resource available that can sort through. We sort transformers. Is it critical to the mission of the whole operation? Is it specific to one part of the plant, or is it's like a lower risk transformer if there's a problem? They all have a different story, and the story has to be integrated with how much money you can spend in maintenance, how much you'll save if there's a problem, all the way to the biggest monitoring program that you could put on a transformer is valuable on one, and on something smaller, it's of no use and not even practical. So you touched on, Emilio, that the people that make the decisions have become fewer and fewer as they retire or move on to different things. So the knowledge base has to be presented in a way that the user can understand and get the value propositions that you mentioned, Brad, in front of them, so they can help, you can help them make decisions.
Any great movement starts with a champion, right? Someone has a vision for it. And this is a great movement. This is critical to the industry. No matter what industry you're talking about, we are at a critical state. We've got to keep the aging infrastructure working until we can replace it. And because some of these now are not 6 months, they're 3 years, you better do something now. So Mark, you get the last word on all of this.
So, I've been a big fan of, trying to make it a program and getting the data out of the field and making it more visible for day one. I mean, sharing up, personal experience. I mean, the real value for that. If you can get that data and make it easily accessible, when you have a problem, it's going to be, you're in a better position to make those decisions and truly manage the asset properly. But the other thing is as you make that data available, there's going to be people that navigate to and have that skill set to analyze it. So we talk about retiring SMEs and things like that and how we're strapped and we don't have enough of them. I'll give an example. When I was at the utility, we had initially one guy that analyzed DGAs. That was, and in the end, it turned out that, a lot of us had that capability to analyze the DGAs, but we needed access to the data.
Yeah.
So if we can make the data available and give them the tools, the Duval triangles, pentagons, things like that, and the ratios and things like that, make the diagnostics available to them, others are going to navigate. And, now you can start getting that down to an electrician level or maintenance, other people are going to be able to do that, and help you with that. So that's really some of the value add, is that you can start, spreading the responsibility for reviewing the data across multiple, departments and multiple individuals, which, helps you really grow as an organization. And
so there's a concept within the SMRP world and in the Safety and Reliability Association world, which is an organization that I was fortunate enough to help co-found, but it is operator-driven reliability. And that is getting the decision-making down in there so that the data management, the data analytics, that the guy in the field can take this and go, oh, I probably need to go and look at that. I got an alert, an alarm. I need to do something about it, and not just have it filter up here at one level, but get everybody involved in it. Now it's moved to operator-driven safety and reliability, because it's their own safety that we're talking about. So let's move to the next part of this. I want to thank all of you for being part of this, and we want to take a couple of minutes each and talk about your companies, exactly what you're doing, and give a little bit of a brief on it. Emilio, let's start with Qualitrol. Let's talk about what it is, and thank you, and thank your folks at Qualitrol for sponsoring this.
Oh, thank you. You're welcome. Yeah, basically our Qualitrol approach is moving from, sounds weird, but because that's what we've been talking about, move from data providers to actionable information. So as I said before, I mean, we look into the different assets that we provide monitoring systems for, and look at the different components, the different failure modes, the symptoms, the parameters. We work in the correlation of those parameters, and we can and provide what type of failure mode we may have on that transformer. There are some of them that may be very similar, so at least we can point out one or two. And the idea as well is to provide actions of what to do in the case of something like that happen. And to make it things a little bit more, complement, we came out with, let's say, different packages for depending of the needs of or budgets or the type of transformer. of comprehensive monitoring systems. And one of the characteristics of as you go at a better comprehensive monitoring system is speed, how fast you can detect something before it happens. So it's coming along with that as well. So we have some solutions. We had all those things already pre-configured. So that's what we're looking, and knowing what's going on with new units, or what is now taking place. We try to focus on the retrofit market to try to, make things to happen to those units in the field in a way that can be done. So that's right now our approach. We're working on that right now.
Thank you, thank you. And Mark, Dynamic Ratings, I love your company. One of the very first things we did at APC Media was I interviewed Tony. Your, I think he's the charge now of global when Wilson Transformer got him. Brilliant man. I love that interview. It's somewhere in our website there. But talk a little bit about Dynamic Ratings and what you all are doing in the marketplace.
Yeah, so from when you first interviewed Tony, things have really evolved. Back then, Tony would have talked a lot about, just the monitor and things like that. And we still make some, some great monitors for, breakers and transformers and stuff like that. So you can actually monitor your critical assets. But we've really evolved into more of a solution provider, making sure that you're not just putting that monitor and leaving it sit in the field, that you're actually getting the data back into SCADA, encouraging customers. It's like, okay, what about your dashboard view? So we continue to drive them and get them, to try to help with their vision, really, as to where they're going to go and what they're going to do with that data and information. Because as Emilio said, you need to take the data and turn it into information. And so we spend a lot of time on that. And then the next piece that we're focusing on now is challenging companies on, okay, you have the data and information. Next step is let's migrate away from the time-based into condition-based maintenance. So making sure that they're leveraging that data. So we try to be a full service provider. We recognize early on that it's not just all about the monitor. It's about getting the data and what else are you going to do with it and leveraging that data. So we have a program that we call our live stream program, where it's it's really whatever area you need help with, whether it's the planning of what you're going to monitor and things like that. Is that on the implementation side, making sure you can get this installed in a timely basis and reduce, because outages are very costly. So, even a planned maintenance outage, nobody wants to take it out for 2 or 3 weeks. So how can we reduce that down to, a couple of days or even less than a day, just to, to get the online stuff installed, so that, because that's important to them. So it's really every aspect: designing, what you're going to do with the data, managing it, and even once it's installed and running, basically the support end to, help you analyze the data, and even giving some guidance as to, managing your risk. What's this really mean? And do you need to take this out today, or can I actually, continue to monitor it and move forward from there?
Excellent, excellent. Bob, what's SDMyers doing in the marketplace now?
Oh, thanks, Alan. Well, we're in thousands of facilities a year with many, many transformers. We find statistically 20 to 25% of the transformers we look at need some attention. So where we have time-based monitoring, we have condition-based maintenance. And we find that this year, I think we corrected problems that could have resulted in failures in some 1,200 different transformers at hundreds of sites. And the availability of transformers, again, is weighing into this, because you've got to take care of what you have, and then be prepared for the inevitable that transformer is eventually going to lose its, if we end at end of life. So we're on that end as well. We like to have all of our data roll up on our dashboard for our customers with IR, PD, visual inspections, electrical testing, monitor data, and of course, all of our chemistry data, visual inspections on gauges. You know, a low level can ruin a transformer and shut a plant down. As simple as that is, just reading the two gauges, the level gauge and the temperature gauge, and making sure you've got the right amount of oil in the transformer. Smaller ones, especially when you're sampling them, eventually they run out of oil or they run low to where they won't cool properly. So we like to have all this data roll up into our health center and provide customers with a map of where they should put their attention. So it's right in front of them in a way that they can say, I got to make sure I'm looking at these 10 out of 100 as a priority.
Excellent. Yeah, excellent. We'll talk about that in a minute. Brad, systems with intelligence.
Yeah, our focus over the last 15 years has really prioritized the substation environment. You know, we know the substation environment has a lot of harshness components from an electrical perspective, EMI, EMF, as well as all the temperature impacts and remote aspects of the substation. So, you know, we've built our company based on having substation grade thermal and visual cameras and sensors. And the premise behind our solutions is to do continuous monitoring. So one, to be able to identify hotspots that are occurring in real time, as well as being able to trend the thermal data and bring that back to a data and analytics group to look for trends that can be correlated with other data sources. We also have typically historically been using our visual system more for situational awareness and, you know, doing remote operational reviews and the such when an event is going on. But what we're seeing right now is we're starting to really see an acceleration of using our visual system to do remote asset inspection. So, you know, if you look at the advents of computer vision and where things have gone, we can really use our video and imagery from a remote perspective and proactively and autonomously do the visual inspection work that boots on the ground in legacy processes would have been doing. So really seeing a coming together of thermal and visual to help monitor from a touchless perspective the substation environment. But we also really see the power of our solution being complementary to other sensors in the marketplace. The power of monitoring a substation is bringing together DGA data, bushing data, thermal data, load performance data, customer criticality, transformer criticality, all of these pieces of data together, and then making a more informed decision. So we really enjoy working with our customers on that broader strategy and being a portion of the solution.
Excellent. One of the things about our sponsors, so let me give a plug for all of you. When you come to sponsor one of these, you do two things. You bring an expert. These are the experts, the subject matter experts from these sponsoring companies. But you come to do one thing, and that thing is to educate the marketplace, let people make wise decisions. And today, there's less selling that's going on and much more evaluation that's going on. But all four of these companies I can highly recommend in their space: Systems with Intelligence, Qualitrol, Dynamic Ratings, SDMyers. They educate the marketplace, and I can tell all of you over the years have done a great job to bring in content that people can go to their bosses and use. But thank you so much for what you do for the marketplace, for our 27,000 subscribers that are listening to these and hearing these. So I appreciate that very much. We do have a lot of questions. We don't have a lot of time. One question that it's two questions in one. And it relates to GIS. So let me ask it this way. Would it be advisable to employ gas-insulated, I guess it's gas-insulated switchgear and connected to the transformer instead of oil and solid installation to avoid insulation failures? I don't even know where to go with that. Somebody pick that and answer it.
Well, the only thing that I can tell you is GIS is basically applicable in those places where the real estate is not available. That's one reason, I mean, for people using GIS.
Okay.
So,
Okay, that answers that question. Another question that we've got is, because we have one more minute to do this, but another question we got, I got to get my technology working here, is one that says, oh, here it is. No, that question's, you just kind of answered it also. Well, this has been wonderful. We've run out of time. It's a full hour. It's amazing how you plan these things and everything worked the way it was supposed to work. But once again, I thank you individually, Brad, Emilio, Mark, and Bob, but I also thank your organizations for supporting this. This has been an APC Media presentation, and thank you for joining us.
Thank you, Alan.
Bye.
Thanks, Alan.